Hey everyone. Okay, so I'm gonna go ahead and pick back up off of what I was talking about on the last set of notes. Essentially, whenever you use the factor theorem and you figure out that a polynomial is indeed a factor of another polynomial. So, let's refresh our memories back to this example. So, I gave you the polynomial 2x cubed minus x squared plus 2x minus 3, and I gave you two other polynomials, x plus 2 and x minus 1, and I wanted you to figure out if they were factors of the original. So in part A, we noticed that once we substitute in our factor into our polynomial, we do not get a remainder of 0. So x plus 2 is not a factor. However, in part B, we see that once we substitute in our value of 1 into our polynomial, we get a remainder of 0. So we do know that x minus 1 is indeed a factor. So I'm going to go ahead and kind of pick up off of that and show you once you have gotten a remainder of 0 and you verified that x minus 1 is a factor of the original polynomial, then you can now take it a step further and factor the polynomial completely. And remember, these are all polynomials that you can't use the quadratic formula. You can't use traditional factoring of any of these sorts, right? There's no GCF you can take out. There's not a difference of squares. There's not a sum of cubes. There's not a difference of cubes. It's not a trinomial that you can do the X method with, and you can't factor by grouping. So it's like none of these cases work, but you're still expected to factor. So you go ahead and use the factor theorem to figure out if one of the polynomials that they give you that is a factor, which in this case we found out that it is. So now that you know that x minus 1 is indeed one of the factors, you can go ahead and do what you guys know about synthetic division to figure out the complete factor form. So that's what we're going to go ahead and pick up off today. The title of these notes are going to be called Factoring Higher Order Polynomials. So just refreshing our memory, or just to kind of rewrite it on these sets of notes, like we said, the original function was f of x is equal to 2x cubed minus x squared plus 2x minus 3. And we have already verified that x minus 1 is a factor. And how did we know that it was a factor? Because remember, x equals, because f of 1 was indeed equal to 0, right? We checked that out. When we substituted in 1 into our polynomial, it gave us a remainder of 0. So we knew that it's a factor. So now that you know that that's a factor, one of the factors, you can go ahead and figure out the other factor to factor this polynomial completely, which is what we're going to pick up off today. So for today's, all of the second polynomials that I give you that are going to be of, remember, a degree of 1 and have a coefficient of 1, you can go ahead and use those to figure out the second factor to the polynomial. So you're going to go back to using synthetic division, where the value of x here that makes this equal to 0 is a positive 1. So you're going to go ahead and put a positive 1 on the outside of your division symbol. You're going to do your synthetic. You're going to fill in your coefficients. So in this case, I'm going to put in a 2, a negative 1, a 2, and a negative 3. Remember, you always bring down the first term, and then you multiply and add, multiply and add. So 1 times 2 is 2. Negative 1 plus 2 is 1. 1 times 1 is 1. 1 plus 2 is 3. 3 times 1 is 3. Negative 3 plus 3 is 0, right? And indeed, we already knew that we were going to get a remainder of 0 because we've already verified that x minus 1 is a factor. So now that you have this, you can go ahead and rewrite these terms. Remember, you're going to take 1 less of the original degree. So if I start off with a 3, then my factored form is going to be a squared. So this is going to be 2x squared plus x plus 3. And that right there is my second factor. So if I was asked to completely factor out the original polynomial, you can say that 2x cubed minus x squared plus 2x minus 3, in factored form, that is equivalent to, well, x minus 1 times 2x squared plus x plus 3. We have went ahead and taked our original polynomial and factored it using the factor theorem and some synthetic division. You have my word, if you were to go ahead and FOIL out this binomial, combine your like terms, you would get the original polynomial. Remember, factoring is all about the manipulation of algebra so that you can represent polynomials in equivalent forms. Okay, so this is just a second step that you can do after, or if a question asks you to factor a polynomial completely, and you cannot use any of these other methods that we learned in the beginning. Okay. So let's try one more just to factor some higher order polynomials. Once you've already verified that one of the, they will give you one of the factors though, okay? So this was example 1. Let's try another one. This is going to be, you guys will get some extra side practice on this. You actually don't have, from the textbook, they don't give you practice on this, or they don't ask you to do it. So I will just be giving you guys some extra practice. So let's go ahead and let's try 3x to the 4th minus 6x cubed minus 5x plus 10. And I am going to, like I said, I'm already going to give you one of the factors, and you're just going to factor it completely. I am going to go ahead and give you guys the factor x minus 2. So x minus 2, you already know it's one of the factors. How do you know that? Because if you were to substitute in f of 2, mind you, I need to write f of x in the front here. If you would indeed get 0. Okay, I'm telling you that. I'm telling you that already. Remember, if I didn't have told you that, then you would need to do what we did over here on these sets of notes, where you just substitute it in and then you verify you get the 0. But I'm telling you, you're going to get the 0. So now that you know that x minus 2 is one of the factors, you're going to go ahead and figure out what the other factor is so that you can factor the this top polynomial completely. So let's do some synthetic division. I'm going to go ahead and put my 2 on the outside. I'm going to fill in my coefficients. Be careful here. You are missing an exponent. You go from 4 to 3. No 2. You're missing the 2. You have the 1 and then the nothing. So you need this to fill in, leaving a 0 for that one. So this will be 3, negative 6, 0, because I'm missing my squared term, negative 5, positive 10. All right, we're going to go ahead and bring down our 3, and let's do some synthetic division. Multiply and add. 2 times 3 is 6. Negative 6 plus 6 is 0. 2 times 0 is 0. 0 plus 0 is 0. 2 times 0 is 0. Negative 5 plus 0 is negative 5. 2 times negative 5 is negative 10. 10 plus negative 10 is 0, right? We were expecting that remainder of 0. We already knew it was a factor. So now with that, we can go ahead and rewrite this. Obviously, I started off with a degree of 4. I'm taking away 1. So this will be my 3x cubed term. I don't have an x squared. I don't have an only x. I only have my minus 5. So this, to rewrite the original polynomial in factored form, it would be 3x to the 4th minus 6x cubed minus 5x plus 10. That is equivalent to my first factor, which was x minus 2, times my 3x cubed minus 5, okay? And that is this an equivalent way to represent our original polynomial in factored form. Okay, again, you can FOIL it out and you would see that it would give you the original. All right, so that is a way to factor polynomials. It's another way, right? You guys already know all of these ways, using GCF, difference of squares, sum of cubes, difference of cubes, using the X method, factoring by grouping, and this is now another way. If they provide you with one factor that you know has that remainder of 0, then you can use synthetic division to figure out the second part of the polynomial. All right, copy down these notes. If you have any questions, let me know. You guys will get some practice on this.